Hello and welcome back. Today we are pitting two AI coding assistants against each other in an epic coding showdown. And no, not the kind of showdown with boxing robots, unfortunately. We have Cursor's GPT-5 Agent Mode on one corner and GitHub Copilot's GPT-5 Mini Agent Mode on the other. Both claim to turbocharge your development, but which one actually delivers better code? We will run 3 identical coding challenges, a backend, a frontend, and an infrastructure task through each AI and see how they perform. Along the way, we'll score them in 4 key areas: code quality, prompt fit, production readiness, and working functionality. Each challenge is scored out of 10 points based on those 4 areas. Before we dive in, let us quickly introduce our contenders and how they differ. Cursor GPT-5 Agent Mode. Cursor is an AI-first code editor built on VS Code. It integrates a full-power GPT-5 model directly into your workflow. It's like having ChatGPT in your IDE, aware of your whole project. Pricing-wise, Cursor is $20 a month for Pro. This has limits based on GPT token usage and can be approximated to around 500 requests per month. The prompts in this video resulted in a cost of around 62 cents. Its role is a super smart IDE buddy to generate code, refactor, and debug with context, and runs as an agent to perform multi-step tasks. Copilot GPT-5 Mini is the VS Code extension that now offers agent mode. Under the hood, we'll use GPT-5 Mini, a smaller and faster variant, although we will discuss other models at the end of this video. GPT-5 Mini is fine-tuned for coding and tightly integrated with GitHub and VS Code. Pricing is a flat $10 per month subscription, or you can code with no limits. Its role is an AI pair programmer by your side as you write, suggesting lines or whole functions, and the agent mode takes it way further, taking high-level requests to edit code, run tests, and more within limits. It's far more than autocomplete now. On paper, you might think the bigger model means better code, but is that true? One of these AIs face-planted on a crucial task. Stick around for the summary at the end. I'll explain the results and suggest ways to get the most out of your AI agent helpers by using the best models for the job. If you like seeing DevOps tools go head-to-head in this fashion, let me know with a like and a sub so I know to make more. We ask both tools to build the same simple backend, a small web API for an item service with a database. The prompt describes setting up an HTTP server, connecting to a database, and exposing a couple of endpoints. Here is how each AI tackled it. Here's the prompt. Pause to read it. I'll explain the prompt format shortly and why it's different from what you might expect. Cursor's attempt at the backend prompt. I'll switch to Cursor's GPT-5 agent and paste the prompt in. Cursor generates a FastAPI server with an items endpoint. It structures files, creates route handlers, and moves fast. At first glance, the code looks solid. Proper functions and comments, but I do notice a problem. The code references a .env.example, which it didn't create, and assumes an env setup without defaults. That is a potential showstopper. So, does it run? I start the server, result, error as expected. It fails to connect to SQLite database as it's not configured, nor does the README suggest how to set it up. Not good for working functionality, and no, I'm not going to work through it and fix it. Why should I be expected to write code in this day and age? Now Copilot's turn. The same backend prompt, I fire up Copilot agent and select GPT-5 Mini and feed it the prompt. It opts for Python with FastAPI as well. It lays out app.py with items endpoint, uses a SQLite database. Crucially, it provides the envars required to start in the README. In about 2 minutes, it produces a complete API server. Time to run the Copilot backend. The result? Success. The server launches first try. Get items responds, functional out of the box. The contrast here is stark. Cursor fails to run and Copilot runs smoothly. Let's score this round. Code quality. Cursor attempted a more complex setup, but missing vital config drags it down. Cursor 5 out of 10. Copilot is simpler, yet clear and self-contained. 8 out of 10. Prompt fit. We asked for a working API. Cursor wrote one, but it didn't run. It misses the spirit of usable delivery. 4 out of 10. Copilot met the brief and worked. 9 out of 10. Production readiness. Cursor is not ready. No config with a lackluster README and failure to launch. 3 out of 10. Copilot is robust for a demo, uses same defaults, not prod grade, but a sound start. 6 out of 10. Working functionality. Cursor, 2 out of 10. It would take some effort to get it running. Copilot, 9 out of 10. I only had to manually add the environment variables and it gave me the command to do so in the README. Next up, the front end. Will Cursor stage a comeback or does Copilot keep the streak? But let's talk about the prompts first. The prompts are intentionally lacking technical specificity to see how each agent interprets it. Think of them as a requirement a project manager might give you. For best results from agent modes like this in the real world, be sure to include at least language, task, inputs, outputs, constraints, and context. Challenge 2, the front end. We asked both to create a UI that talks to the backend, a React app that lists out items and adds items via the API. Identical instructions for both. The Cursor front end. Starting with Cursor for consistency, Cursor picks React with TypeScript. It builds a single page app, a form to add items, and a list to display the items. The code uses useEffect to fetch from the API. Basic CSS is included, but it assumes the backend at localhost 8000 is up. In our case, Cursor's backend never started. There's no fallback. I start the dev server, it compiles, and the UI opens. I see a form and an empty list. Network calls fail, of course, no items shown, and posting an item fails. However, the UI does show an error. Net effect, the Cursor frontend is non-functional in practice because the backend is absent. With a working backend, it likely would function. I'll decide whether to punish it for that or not in a moment. Copilot frontend prompt. Copilot also uses React TypeScript in our run. It creates app with a form and lists, adds conditional rendering and basic error handling, shows loading and failure messages, and calls the same API endpoint. I run the Copilot UI, it compiles and opens. With Copilot backend still running, it fetches data, list populates, and adding an item works, and it shows up after a refresh. With the backend, it is a full end-to-end demo. Front-end scoring. Code quality. Cursor's TypeScript is solid, 7 out of 10. Copilot is simpler, yet practical with state handling, 6 out of 10. Prompt fit. For this, I'm giving both 8 out of 10. Production readiness. Cursor adds basic UX safeguards, 8 out of 10. Copilot, no validation or safeguards, 6 out of 10. Working functionality. Cursor renders and would work if not for the backend. I won't punish it for that here. 10 out of 10. Copilot works as intended but can fail due to no input validation. 9 out of 10. Round 3. Terraform Throwdown. Challenge 3 is infrastructure as code. Write a Terraform config to deploy the app infrastructure. Cursor infrastructure prompt. Cursor writes HCL, adds an AWS provider and opts for ECS and an S3 static site. At first look, it's plausible, but syntax is off. Single line variables with multiple attributes and broken blocks throughout the code. It should be relatively low effort to go through and manually fix. Unfortunately, there's no devs here, so sorry about that. The script is not deployable without fixes. Practically a fail. Copilot infrastructure. Copilot writes a more structured config. AWS provider and using a modular structure with scalability in mind. However, one slight issue, all of the files are empty placeholders. The Terraform does validate successfully, but really there's nothing there. Infrastructure scoring. Code quality. Cursor, 2 out of 10. Syntax errors, it's a mess. Copilot, 5 out of 10. Correct, clear, but empty files. The prompt fit. Cursor attempted the resources, but it's not valid. 5 out of 10. Copilot, great use of modules, but failed to write all the code. 5 out of 10. Production readiness. Cursor, 5 out of 10. Not deployable. Copilot, 3 out of 10. Only a skeleton of what's needed, and that's not what we want. Working functionality. Cursor, 2 out of 10. No infrastructure created. Copilot, 5 out of 10. Infrastructure validates, but there's very little there. After we check out the final scores, we'll take a look at the various model options and the best use cases for each to help you get the most out of your AI coding assistants. Right, the judges' scores are in. Well, the judges' scores. My scores. For the backend, Cursor, 14 out of 40. Copilot, 32 out of 40. For the front end, Cursor, 33 out of 40. And Copilot, 29 out of 40. And for infrastructure, Cursor 14 out of 40 and Copilot 18 out of 40. A real letdown from both sides on this challenge, which I find quite odd given how simple HCL Terraform is compared to the other languages. Well, the pattern is clear. Copilot produced more usable and correct solutions. Cursor often fell short despite the more powerful model. So, our winner, Copilot. Hooray! Well done, Copilot. At the cheaper subscription model as well, I would say you're probably getting more bang for your buck. So let's talk about these assistants, different models and use cases. When using Copilot or Cursor, here's the lowdown on which models to use in given scenarios. Use GPT-5 or Codex when you want fresh code generation that is ready for production, and pick GPT-5 Fast or Mini when speed and low latency matter more than depth. Choose Claude 4 or 3.7 for reasoning on complex logic or detailed refactors. Turn to Claude 4.1M or Gemini 2.5 Pro to handle very large repos and specs. Claude Opus 4.1 and GPT 4.1 shine when making design and architecture decisions. For multi-model work like docs plus code, use GPT 4.0 or Gemini Pro model. Grok Code and its fast version are for rapid drafting and quick fix cycles. O3 Mini and O4 Mini are cheap helpers to plan and edit small tasks with speed. There are a couple of reasons why you want to use older generation models. A, to save money, the per token cost is generally less. In some instances, you'll get faster responses with the cost of less accuracy. Otherwise, it will be because your older generation models can be more stable and predictable. Want to see Copilot showdown against another AI tool? Watch this video where we showdown against GitLab Duo. You might be surprised by the results. Like and subscribe to Merge Ready for more tests, tutorials, and real-world breakdowns. Until next time, stay Merge Ready.